Okay, so next topic is meta-analysis. So for meta-analysis, remember the term PRISMA, preferred reporting in preferred reporting item for systematic reviews and meta-analysis. Okay, so what is meta-analysis? It's a use of statistical methods to combine the results of individual studies. Very simple. Use of statistical methods to combine the result of individual studies. So this is point one. Point two, to determine more precise estimate of the treatment effect. Point three, applied to the studies of interventions and most often RCTs, randomized controlled trials. And the four is applied to the studies of diagnostic techniques and epidemiological studies. Okay. Next is, what is a systematic review? So again, 4 points for systematic review. One, secondary research study. It's a systematic review is a secondary research study in which a literature review is conducted according to a strict protocol in order to identify all the studies relevant to the question under consideration. So question is very important, and we have to go through all the studies which includes that question. Point number two, they often include attempts to identify and obtain data from unpublished studies relevant to the question at the hand. Three, rigorous inclusion and exclusion criteria are applied in order to ensure that no selection bias occurs. Number five, we have to follow with the current PRISMA guidelines. So do systematic reviews and meta-analysis provide a high level of evidence? I think yes. So systematic review and meta-analysis of high quality homogeneous RCTs currently constitute the pinnacle of hierarchy of evidence. That's on the top of the evidence on our hierarchy, ranked as level 1A. What elements comprise a good systematic review or meta-analysis? Again, it should have a well-constructed, relevant clinical question, ideally expressed in PICO terms. PICO is again a mnemonic, so P for population, I for intervention, C for control, and O for outcomes. PICO. What is PICO? Population, I for intervention, C for control, outcomes. PICO. Population, intervention, control, outcome. Okay. And do you know commonly used pooled outcome measures in meta-analysis? So its continuous variables are like length of stay. They are usually pooled in form of weighted mean difference. So continuous variables. So there is no change. Other are the categorical variables like death, yes or no, are often combined in the form of pooled odds ratio for intervention studies and risk ratio. Okay. What are the advantages of meta-analysis compared to the traditional literature reviews? Meta-analysis. So again, there are 6 points for advantages. Number one, meta-analysis controls far between the study variation. So different research studies control the variation. The result can be generalized to the study population. It allows an evaluation of whether bias exists in the literature or not. It's a greater statistical power to detect an effect than a single study would. So statistically, it can it has a greater statistical power to detect effect than a single study. And point number five, it provides more reliable synthesis of available literature, allowing clinicians to cope with information overload. Okay, so like if some topic has 10,000 publications, how a clinician can go through the 10,000? So he can just read some systematic reviews of that question. And the last point, the sixth point, is that by combining results from self-study, it is likely to be influenced by local factors peculiar to single institutions. Next question, are there any disadvantages to meta-analysis? Yes, 3 points. Pooling results from several small studies may not reliably predict the results of a single large study. If the source studies are poorly designed, meta-analysis will produce unreliable results. They are vulnerable to publication and agenda-driven bias. So here is a question that while doing the systematic review, you have to select the studies who are properly designed and who have a good sample size instead of a smaller studies which can change our results. So what is publication bias and how it is tested for? So studies with the positive results are more likely to be published than those with negative results. So this is a bias. So why they don't publish with the negative results? Meta-analysis is restricted to publication studies only may produce an exaggerated effect size estimate as the unpublished studies with negative results are missing. So publication bias is detected using a funnel plot. A funnel plot. Funnel plot exploits the observation that in small studies effect size estimate should vary quite a lot, while in larger studies the variability should be much less. Consequently, a plot of effect size estimate. Let's move on. Why do a meta-analysis? Why not simply add up the results of all individual studies? This is known as the pooling participants approach. Mixing participants from different studies and calculating a simple effect size estimate negates the effects of randomization. So it doesn't come in the domain of randomization. It also gives the equal weighting to all the results rather than taking account of more precise results from the latest studies. A meta-analysis avoid these pitfalls by calculating an effect size estimate. Effect size for each individual study, and then assigning a weight to each study based upon the sample size to generate an overall summary effect size estimate. So can you explain how to interpret a forest plot? So in meta-analysis, data are presented in a format called the forest plot or meta view. So in the forest plot, on the left side are the studies that are included in the analysis, and there will be a year in which they are published. The next column usually shows the number of patients that were involved in the frequent treatment group, and area on the right side of the forest plot shows the results. The central line is known as the line of no effect, where there was no difference in the outcome between the treatment and the placebo groups. Anything on the left of this line favors treatment. Anything to the right favors control. So all studies are important if they are on the left side of the line. Each study is shown by the point estimates of odds ratio, which is represented by square proportional to the weight of the study. 95% for risk ratio, summary odds ratio, and 95% by random effect calculation are represented by a diamond. So what is the difference between fixed effects and random effects model in meta-analysis? The random effects assumption is that the individual specific effects are uncorrelated with the independent variables. The individual specific effects are uncorrelated with the independent variables. The fixed effects assumption is that the individual specific effects are correlated with the independent variables. I don't know what it is. So let's go to, so that was all about meta-analysis.